So what we're going to look at here, so this is quantitative, so all reactants are used up. Used up in reaction 1. So what we do with a polyprotic reaction is we take this guy. So remember, HCO3 negative can be an acid and a base. So this guy is going to end up being my base. So HCO3 negative plus H3O plus. And that's going to make H2CO3 plus H2O. So again, we donate a hydrogen. Now this is all in your acid-base chart as well. You can see that there's a conjugate acid-base relationship between HCO3 negative and H2CO3. There's also a conjugate acid-base relationship between CO3 negative and HCO3 negative. So when I put all this together, I'm going to cancel that out. Okay, and I'm going to get CO3 negative plus 2H3O plus. So this is my net reaction. H2CO3 plus 2H2O. All right, and that's aqueous, and that's aqueous and liquid. All right, so that's my net ionic equation. Okay, and when I look at my acid-base chart, this is about 7.8, and this will be about 3.8, and I can identify what entities are present here. So here, right, it's basic, there's CO3 negative, there's Na plus, there's H2O, and then there'll be some H3O plus and Cl negative. Okay, once we hit here, equivalence, so at first equivalence, okay, no CO3 negative left. Okay, and here we'll have HCO3 negative, Na plus, Cl negative, H2O, and H3O plus. Okay, and then at second equivalence, no more HCO3 negative, and then after we'll have H3O plus, Na plus, Cl negative, and H2O. All right, so as we keep going, we move through the polyprotic entities of the base. All right, so we'll use up all the CO3 negative as we continue to add hydronium, and then we'll use up all the HCO3 negative. Now this reaction is quantitative. This reaction, because it has a weaker Ka, Kb value, will more likely end up as an equilibrium reaction. But it depends on how much acid we add. Okay, so this first reaction will definitely be quantitative. This one will be quantitative if we add enough acid to it. Okay, so that's polyprotic. I'm going to have a couple more examples for you like that. But we developed this titration curve from this word problem. Okay, I'm going to end that right here, and then I'll give you guys another example in a separate lecture.